everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about graphing linear inequalities and systems of linear inequalities. They are very closely intertwined and you're likely to see them both at the same time, so we're going to cover them both today. So this is not, to be clear, this is not graphing inequalities on a number line. Like if they ask you to graph x is greater than 3 and they give you, the little line and they want you to draw those open circles and such. No. That is not what this is. That is a separate video and a link to that is in the description below if you need help with number lines. Let's get rid of all that. Wow, that's really noisy. I have a lovely new microphone and it picks up everything, including the slightest move of my mouse. All right, there we go. I'll have to remember that. So today is actually graphing the inequalities on an XY graph, and these are linear inequalities. So let's just take an example of one all by its little lonesome. And let's say we had let's make that straight. There we go. I had a nice little XY graph. And I'm using the grid that's in the background here. And each of these is just representing one. I'm not doing anything fancy like they each are 5 or they're each 22,000 or something, silly like that. No, these just represent one. Each is one, and we're going to go from there. I'm also going to assume that you know how to graph lines based on the slope-intercept form of the line. If you have any questions on that, if you haven't used this in a while, I recommend you go watch the video on slope-intercept form first. Link is below. Again, just going to assume that you know what I'm talking about when we graph these. Okay, so here's an example. If I had y equals 2x plus 3, how would I graph that? Well, I have my y-intercept there at 3, and let's put this in red. And I know my slope is 2, so I go up 2 over 1, down 2 to the left 1, and I've got this line that goes up and goes down this way. And that's my line, y equals 2x plus 3. Done. Woohoo! I can go home. Well, what if they changed this? What if they changed it to y is greater than 2x plus 3? Well, this line no longer shows the solution, because that's what a graphing is. A graph is showing a visual of all the possible solutions to this equation. Well, now it's not the things that are equal to it, it's the things that are greater than it. Okay, first off, I have to change this line, because the line as it is represents y equals, and that's not true anymore. It's only y is greater than. So anytime it is a greater than or less than, not talking about greater than or equal to, less than or equal to. No, we are not talking about those. We're only talking about greater than or less than. When you have those, you need to make your line dashed. You need to have it as dashes. That's very important. I guarantee you it will be marked wrong if you don't do that. So the next thing we need to do is there's a lot of x's and y's that would make this equation, y is greater than 2x plus 3, true. And we have to show this by shading. But unlike a number line where you just take a point and then you shade right or left, this one we have to shade a whole area. So either the top, the part above it, or the bottom, the part below this line. Which one is it? The general rule of thumb is when it is y is greater than, then you're going to go above. And when it's y is less than, you're going to go below. Well, as you can see, it's getting more and more vertical. It can sometimes be difficult to say, below? Is that really below? It's more to the left or the right. How do I know this? One way that is guaranteed that you will always know the right side to shade is you pick a point that is not on the line and plug it into these x and y coordinates and see if it's true or false. So I always like to go with 0, 0 if it is not on the line, and woohoo, in this case it's not on the line, so I can use it. So I'm going to use 0, 0 as my test point, and I'm going to plug it in there. I'm going to plug in 0 for x and 0 for y. So 0 is greater than 2 times 0 plus 3. So 0 is greater than 0 plus 3. 0 is greater than 3. Is that true? No, that's not true. 0 is less than 3. So I know that the side of this line where 0, 0 is not the solution. It's going to be this side up here. And check with your teacher if, she's okay with you like cross-hatching, or if she wants you to use colored pencils or something. Just do whatever she wants you to do to show the solution to this. Right, so that's graphing one of these linear equations. Now, the next part of this is going to be when they give you a system of equations. And when that happens, you're only going to shade your final answer. You only shade where they overlap, because that's the solution. Only values that are in both of these shaded areas is going to be the solution, only the overlapping area. So here's an example. If I said y is greater than or equal to 2x minus 3 and y is less than negative 3/4 x plus 4. Okay, so I'm going to graph each of these separately, and then I'm going to graph my final solution. So first, y is greater than or equal to 2x minus 3. Because it is a greater than or equal to, it's going to be a solid line. That's the other thing. I don't think I said this specifically previously, but because greater than or less than, the line is not part of the solution. For greater than or equal to, less than or equal to, the line is part of the solution, so graph it with a solid line. So y is greater than or equal to 2x minus 3. I'm going to do this in, let's do it in green. Ooh. So my y-intercept is negative 3, and my slope is 2, so I go up 2 over 1, and then go up 2 over 1, and then I have my line there. And it is a greater than or equal to, so it is a solid line. Now, which side would I shade? I'm going to use my little test point of 0, 0 and say, okay, I'm going to plug that in. Plug in 0 for y and 0 for x. 0 is greater than or equal to 0 minus 3 or negative 3. Is that true? Yes, it is. 0 is greater than negative 3. So because that is true, I want to shade the area that contains 0, 0. So it would be all this area. So that's the first one. I missed a little bit up there. Okay, it's all the way up to the line. I know it's not precise here, but you have to be right. It's right up to the line is what we're trying to show. So second one, my second equation that I'm going to do, y is less than negative 3/4 x plus 4. And I'm going to use, what is that? Fuchsia, magenta. I'm going to use that color. Y is less than negative 3/4 x plus 4. My y-intercept is 4. My slope is negative 3/4. So I go down 3, 1, 2, 3, into the right 4, 1, 2, 3, 4. We're going to I'm just going to use the ruler because I need to make this a dashed line because, again, this is a less than. So it needs to be a dashed line. So I'm going to do it this way and just do a dashed line. There we go. Isn't that nice? So where is y less than negative 3/4 x plus 4? Again, less than or equal to usually means you go below the line. I say usually just because it can be hard to determine what is below or above. I just want to make that clear that, plugging in a number to test is perfectly fine. In fact, I recommend it because it's easy, to be sure. So same thing, 0, 0 is not on the line, so I can use it as a test. So I plug in 0 for y and 0 for x. And I get 0 is less than 0 plus 4, or 0 is less than 4. That's true. So what is the solution to this? It's all this below this line. So those are my two separate inequalities. So what's the final solution? It is only the areas where they overlap. That's it. You have to be careful on this. And again, just make sure you know how your teacher wants you to present that so you don't get counted wrong. It is only this bit right here, the part where they overlap. So I'm going to erase. There we go. So it's only that bit that's in here, because that's where these two things are true. Any point in that shaded area, and it keeps on going forever in all directions over here, any set of coordinates in that shaded area will make both of these true. So I can pick any point, like if I put this point right there and I plug that coordinate into both of these equations, they will both be true. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.